Let's talk about Romberg's method and how to apply. How does it work if we are using several stages? In the last video we prepared the way, we learned the theorem of Romberg, and now we take out the conclusions. Okay, this is our idea. Now let's do the job. Now if we have that line, then instead of h, use h halved. That gives here a h squared divided by 4. That gives here an h to the fourth divided by 2 to the power of 4, which is 16. And then here an h and a divided by 2 to the power of 6. 2 to the power of 6 is 64. And now let's do the job with a quarter. A quarter squared is 1 divided by 16, and then C4 times h divided by 4 in power of 4. We have 4 to the fourth power, which is 256. And here we have a 4 to the power of 6. 4 times 4, 16, times 4 times 4 is 256. Times 4, 1024, times 4, 4096. And now let's improve these two values as we did in the last video. And what do we get? 4 times that minus that, 3f divided by 3 is an f, plus 4 times that minus that is nothing. That's the reason why we did that combination. Now 4 times that is a quarter, minus that is minus 3/4, divided by 3 is minus 1/4. So minus 1/4 C4h to the fourth power. And then here 4 times that is 1 divided by 16, minus that is minus 15 divided by 16, divided by 3 is minus 5 divided by 16. And now let's do the same here. What do we get? An f, that cancels, okay. Then 4 times that is 1 divided by 64, minus 4 divided by 64 is a minus 3 divided by 64, and then let's divide by 3. That's a minus 1 divided by 64 times C4 times h to the fourth power. And then let's do the job here. 4 times that is 1 divided by 1024 minus that. So multiply the numerator and the denominator with the factor 16. So we get 1 divided by 1024 minus 16 of that is minus 15, divided by 3 is minus 5, divided by 1024 C6h to the 6th power. And now we want to combine these two to get rid of the h to the power of 4. And what do we have to do? Let's take now 16 times that, then we get minus 1/4, minus that, these cancel. And then to get 1f instead of 15f, we have to divide by 15. So that's what we have to do. If that is 1 and that is 2, then let's do 16 times 2 minus 1 divided by 15. And we get 16 minus 1 divided by 15 is 1f. Okay, then this cancels, nothing left. And now 16 times that minus that divided by 15. I did that calculation, and the result is a plus 1 divided by 64 C6 times h to the 6th power. And then instead of using t to the h divided by 4. We can also use this expression for h divided by 8. Then we have one more stage. Then we have to do that calculation once more. And then we will find out, here we use the 4 minus 1, 3. And then here this is by factor 4. 16 minus 1. And then always divide by 1 less than here. 16 times something minus is 15. And so we have to divide by 15. So next time it will be 64 and a 63. And then the next stage would be again factor 4. Then this would be 256, I guess. 256 and 255. Okay, so we get the following tabular. We have here the value. This is the trapezoidal value using h as the step width. Then we have here the trapezoidal value for half the step width, the trapezoidal value for a quarter of the original step width, and so on. Let's do the job here for 4 entries. And now we do the following calculation. If this is 1 and this is 2, then 4 times 1 minus, no, not 4 times 1, it's 4 times the better value 2 minus 1 times the more coarse value divided by 3. And then here also, if this is 3, 3 is the same as 2, and then 4 times the better value minus 1 times the more coarse value divided by 3, and here also 5, 6, and 4 times the better value minus 1 times this value divided by 3. And then the next stage, if let's say this is 1 now and this is 2 now, then 16 times the better value, 16 times this value minus 1 times that value divided by 1 less 15. Let's do the same here. If this is 3 and this is 4, 3 again is the same as 2, then 16 times this value, the better one, minus 1 times this value divided by 15. And then the next stage, let's say this is 1 and this is 2, then factor 4 is 64 times the better value minus 1 times this value divided by 1 less, so it's divided by 63. And from here we are using 4 and 16, this is factor 4, and here we are using 64 instead of 16, so it's again factor 4, and it will be always factor 4. And how can we find out that it's really always factor 4? We have to do that analysis. It's a long analysis here, but then we will find out it's always factor 4. I don't want to show that because that is really boring. It will always be factor 4. So now let's do an example. First example. And let's talk about the integral we had in the last video also. It is this integral value. And now let's choose an initial h. The interval length, original interval length is 1. So h is 1 is one choice, but let's start with h is a half. And now we need to decide how many stages do we want to do. So let's do 4 stages here. And so we have 4 stages here. Here the trapezoidal value is 7.2179. How do we find out that? We evaluate at position 2, we evaluate at position 2.5, we evaluate at position 3, then a half times the first value plus 1 times the 2.5 value plus a half times the 3 value, and then multiply by the h, which is a half, and then we get 7.2179. And so let's do the job also for h halved, which is a quarter. Let's do the job for h divided by 4, what is 1 divided by 8, and let's do the job for that, and this is 1 divided by 16. Then we get 3 values, and here we have to evaluate at 2, at 2.25, 2.5, 2.75, and 3, and then all the job, h times first value times a half, second, third, fourth value times 1, and last value times a half again, and then sum up, and then we get these values. I want to do that electronically. Okay, these are the commands. H, we choose h is a half, then x is the vector 2, 2.5, and 3. Then we evaluate at these x values, and then we multiply h times the first value times a half, the second value, in this case it's only the second value, no third, no fourth, no, only the second value, then this times 1, and the last value times a half, then sum that up and multiply, don't forget to multiply with h, and then we get 7.2179 as I said. Okay, now let's exchange h to be a quarter, and now that's our second. Okay, and now we get 6.9749. We will write that on our paper later. Then let's do the job here, and we get our third value, and then we do the job again, and we have these 4 values, and these I will write on the paper. And now let's apply Romberg. Here, what do? We multiply 4 times this value minus this value divided by 3, and then doing so using electronic help, we will get 6.8939. And then we do the same here again, 4 times that value minus that value, divide that by 3, 4 times that value minus that value divided by 3. Let's write it down a little more structured. And now here 4 times that value minus that value, and then this divided by 3, and we get 6.8978. 4 times that value minus that value, and divide that by 3, and you will get 6.8980. And now 16 times that value minus that value, and divide that by 15, and then you get 6.8981. And now 16 times that value minus that value, divide that by 15, and you get, if you write it down with 4 digits, internally I used more digits than I write down on the paper, then we get the same number. So in this case it will be clear what is the answer, because 64 times that number minus that number divided by 63, with these digits it's clear from the beginning, result is that. But okay, these numbers are not really equal, only if we write it down with 4 digits. Let's do that job electronically. Now we have these I values, and now we can calculate these values 4 times these 3 values minus 1 times these values, and then divide by 3. So we have only one command in Octave, and we get 3 results, and these were the results I wrote down on the paper. So we had these numbers, these are the ones from the left, and now let's do the next stage. And we get these 2 numbers, and then let's do the next stage, and we get that number. Let's use more digits in the display, and then we see I are these numbers, I2 are these numbers, I3 are these numbers, and now you see they are not really equal, only to the 4th digit, and then I4 is that value. So this is our guess for the integral value. And by the way, when I prepared for that videos, I observed a strange thing I want to show you. Doing that line, we multiply here, we multiply h times that sum, and let's forget times h. you can write it that way, or you can write it that way. And what do you see? Mathematically, this and this is perfectly identical, but you see here in the end a 9.2 in that version and a 9.1 in that version. And that's absolutely not what I have expected. So you see the last digit is more or less a random number, and very slight differences in doing the calculations may cause a difference. It has to do with the nature of floating point numbers, and here the order of summing is changed from the version above and the version below, and so the result may differ. That's only by the way, that's not the important thing here in that video. Okay, and now you can do as a training, either you start here and you find these 4 values, or you will start here and train what I did here. In the exam, maybe I give you these 4 values and you have only to perform this step, or you have to calculate these 4 numbers. That would be a lot of work. So maybe the chances are not so high that you have to do that, but it's also possible that this is also your job. Okay, so now a second example, which is also very interesting. Let's work with that integral, e to the power of cosine x squared. This is some complicated function. And now let's choose an initial h. Let's choose the interval length 3, so we evaluate only at position 0 and 3, and then the trapezoidal value, and then we get the value 4.6805. Then for h is 3 halved, we get, do that by your own, do that as a training, and you get this value. Then this value is 43748, and this value is 4.7034. Now let's do that job. Stop the video, do that by yourself. Okay, I hope you did. And then 4 times that minus that, 2.6273. 4 times that minus that divided by 3, 4.7862. 4 times that minus that divided by 3, 4.8129. 16 times that minus that divided by 15. 16 times that minus that divided by 15. And 64 times that minus that divided by 63. And we get that value. And the correct value in this case is the following. And that means we are not very close. And let's check the tableau. And what do we see? We see the best guess is that one. So the trapezoidal value is better than the improved versions of that value. So we did not improve that value, but it gets worse doing Romberg. So in this case, Romberg is counterproductive. And why? Why? So this was a training. This training was great, but in this case, I want to give a warning. And this warning means, if you remember when we very first motivated Romberg, then we said, okay, let's use h is 3 and then we get some trapezoidal value. And in this case, this value is 4.6805. Then 3 divided by 2, half the distance here, we get 3.14, this value. Then 3 divided by 4, divide that distance, we get 4.37, and then we are here. And then using h is 3 divided by 8, and we get 4.7, so this value. And you see, without that, we have a convergent behavior, but with that value, this is not part of a convergent behavior. And so it was counterproductive to use that value. We shouldn't have used that value. Obviously, we should not have used that value. But also, without using that value, this would be our improved value, and still it's not better. This value is not better than that one. So at least in these situations, it's clear from the beginning that this value will not be better than the first one was. And that is what I want to tell you. Unfortunately, in this situation, you don't have this hint that your results get worse, but at least in this situation, you have that hint. Okay, so this was our video about Romberg. The most important thing is how do you do the job, and this is that tableau 4 times minus 1 divided by 3, in this stage 16 minus 1 divided by 15, in this stage 64 minus 1 divided by 63, and the next stage would be 256 minus 1 divided by 255. And then you have to find the trapezoidal value, which is a lot of work, or I give you these values and then you perform the Romberg tableau. Okay, so this was our video.